I want to start this video by saying that like the modern 21st century is a data world. And like one of my favorite quote by Edward Deming is like without data you are a person with an opinion. So and I want to bring that opinion that there are a lot of tools on how to do data engineering and data science and machine learning in general. To start with, the most important step in any place when you are starting a data project is like getting an intuition of what the project is. And like as we talk about this importance of data and how can we relate actually like the process of collecting data to a real world scenario. So basically, if I want to say that data is like a really an important entity that has been got involved in our day-to-day lives. And to start with, let's assume that I'm walking on a road, and so I want to build the intuition of how data engineering projects or like how data analysts think or like how businesses are being driven by data. So let me think that I'm a car manufacturer and then I am walking on a road. I just want to analyze the patterns of how the cars are exactly like while I'm walking on the road. I want to see how people are using like different versions of cars and how they are using different models and brands. So for example, to highlight the process of data lifecycle management, I will start going on step by step of important aspects or like important steps in the data lifecycle management. So to start with the generation, like how data is generated basically. So to go back, I started with saying that I am a car manufacturer and I need to analyze the patterns of people who are like using cars on roads. So I want to sit on a bench or on a public road and like just want to record like, say for example, if there are cars passing by me, I just want to sit down and record like what a car brand is, what its color is, what so these are like the physical aspects that I can see right on road. So like what color of the car is, what brand it is, what model it is, or like how good the style of the car is. So these are the patterns that I can visualize that. So in our data world, these are called like the facts, or like I'm seeing that, right? I'm recording those like on my paper or an Excel sheet. And like Excel sheet is way of telling a story. Like for example, I cannot point down all the details that I see on the car. Say for example, the mud has like the tire has some mud on it, or it's like a person who is driving has like different features on it. So it's like I should be able to decide on what granularity I should record the data during the collection process. Say for example, if a car is coming and I have noticed that it's a brand X and then it's like a model Z and then its color is like Z, like A or something. So I just want to chunk that down in an Excel sheet very neatly. And if I go daily to that, like for example, if I go daily to the same road and sit on a bench and record this process over an year, like so I have 365 days of data. And for example, I have recorded all this data and now I have some, and if the traffic on the road was like 100 vehicles per a day, that during the period that I said, during the end of the year I have that 6,500 records to analyze, right? So these are like the facts like that I've seen and I've recorded. And to support my facts I need some dimensions, right? Like say for example, there is, as I'm a car manufacturer, like say for example, if I'm from a brand X, right? So I internally have a database where I record like what are the colors or brands like that I have in general, right? So these are called the dimensions of the data. So when look facts are like what I see in transactions, and like the dimensions support my facts to drive some value on it. So let's say this point of driving value in it, like when we come to visualization step in the data lifecycle management, then we will talk a little bit more on the dimensions, right? So that's how data is generated. And I have like the data is being generated by random people going on that road, and then I started a process of collection by recording the all the features that I'm observing in an Excel sheet or like a pen or a paper or anything. So this is like a general collection and generation process of data. And now I have all the data generated and collected even in my book or in an Excel sheet. Now, once the data is collected, like what do we need to do for processing it, right? So we need to store it and structure it so that somebody can process it and transform it and do a proper transformations in order to see what they wanted to see, or like what the business want to see in general, right? Say now, as the data is stored now, we need mechanisms to automate the process of, say, for example, if I need a new feature based on the feature, right? Say, for example, if I wanted to calculate a number of cars of a particular brand over that day or something and keep track of key metrics, I need to do few transformations. So all the process of the data engineering, like the ETL, ELT parts of it, helps us to transform data in a way that we need or the business need, right? So that's called like the processing step of it. So we clearly do all the data quality checks and like the data processing. Say for example, if I received a call when I'm recording the data and then I missed a car that's walking through, and I can only see its color, not like its proper brand or any model of it. So I might keep those records as null, right? So if somebody is analyzing at later point of time, we need some mechanisms on how to improve the data quality. So that's where the data quality steps come in between the data lifecycle management, where people decide on how to treat the columns, like, or like there are some extreme cases, like there are some no brands that are like ever seen, like people might have made their custom cars. So when I'm analyzing these patterns, like there should be a way how should I tackle the data quality issues that I collected with. So this comes in the data quality pipeline. So after the data collection, we need to do some processing and then like implement some data quality mechanisms to structure our data in a shape that we wanted. So once we structure the data, and we need to have proper policies, right? Say for example, as the car collection process is simple and I can see it like on a road, right? But if I'm collecting data that has some personal PII data, or like healthcare data, or like financial data, so there are regulations that has been enforced by each governments, like on a global scale. And so different countries have different mechanisms of how to enforce the data security or like data privacy. And like this comes in a step called data management, or like how you are actually collecting the data, and how like securely and privately you are accessing the information of a user without revealing his PII data or healthcare data or like financial data. So this is an important step, as like there are a lot of regulatory bodies that constantly monitor businesses for how they are tracking the data and how they are processing it. So it's very important to keep and stick to those guidelines for a business to sustain in long run when they're collecting data and then using some data mechanisms. And now as we have transformed the data, like the data that we collected, we have transformed it, and then we, say for example, I was talking about the dimension tables when I'm talking about the data collection process. Internally as a business, I have few dimensions that actually makes my fact look more good, right? For example, I can only see the like only few features of the car, and say I want to see what engine that car is made of, and it's like what brands of tires that car is used of, like in general, like when I'm manufacturing it. So to add more value to the facts, we add dimensions. Like this happens with like in the regular terminology, when all of our data is in data warehouses, we need to add the value to it. So we use some SQL kind of things to join like all the facts with dimensions, and add features like extra features on the facts to give more insights on our data. And the final and important step is like the analysis part. Here we do a different kinds of analysis. People do like a traditional report building, or they can use data science or machine learning techniques, or they can use advanced techniques, like say if you collect some data like a PDF or something, they can use some LLM techniques to generate the insights based on the data that we collected, right? So this is that step. And once the data is like built as a report, or like once we have generated some models that can predict, say for example, if you want to predict the next car that's selling in your store or somewhere, so you need to use some machine learning or like prediction techniques to do that. So once we are at this point of time, So we are good enough that we generated some insights from the data that we collected. And the final step is like how you archive the data is a very important step. And because algorithms or like the code that you have like structured in your data warehouse can be replicated, but the actual data that I have collected in 2020 during the times of COVID can never be happen. So archival is the very important step in a data lifecycle management, and you should be able to have proper mechanisms in place that should archive your data once you have collected it and then you process it. So thank you.